Now let's do the SOA questions of chapter 3. By the way, as I always mention, most of the questions on the exams of this course are basic questions or standard questions. Those will not be on the same difficult level of those SOA questions. And if you are able to answer all those standard questions correctly, you will be able to get an A. So those are more important. Here we deal with a few SOA questions. That is because ultimately we do want you to be able to pass FM question. That's the reason from time to time I will solve some SOA questions. If you are having trouble answering the standard questions, maybe right now you can skip those SOA questions and come back later when you feel more comfortable. Okay. Now let's look at just the first one, 3.17. This is actually quite challenging question. So let's take a look. Susan invests Z dollars at the end of each year for 7 years at an annual effective interest rate of 5%. The interest credit at the end of each year is reinvested at a different rate. We have never seen this type of question before. This is the very first time your principal and interest grow at different rates. Then we have some accumulated value by the end of 7 years is X. Then there's another person, Lori. She invests the same amount, but for a longer period, 14 years. Her interest rate is much smaller, 2.5%. And the interest itself accumulates further interest at 3%. By the end of 14 years, the account value is worth of Y dollars. We want to calculate Y divided by X. So basically, we will need to calculate X and Y, and then we do the ratio. But before we solve this question, let me use a relatively simple case to demonstrate how principal and interest each grows over time. So let's do a little analysis first. Let's call it analysis. So now let's just look at for 2 years. So this is a completely different case. I want to basically analyze how the principal and interest changes over time. Let's say at time 0, we deposit $1. Okay, that is our principal. So our principal at time 0 equals 1. Assume interest rate is compounded and is once a year at 5%. And obviously at time 1, this principal, let me write it here, 1 will grow to 1 plus I. So in this case is $1.05. That is obvious, right? Now let's do a little analysis. I can say 1-to-1, that is the principal. Principal itself does not change, right? And the interest, the additional 5 cents is nothing but the interest. Okay, so this is at time 1. Now at time 1, if we assume both the principal and the interest will grow at the same rate, then this $1 will grow to $1.05. Let's do the same decomposition. Now we have additional 5 cents. That is the interest, right, over 1 year. Okay, now if we assume this interest grows also at like a here it's 5%. Let's assume it's a different rate. Let me use a different color for this. So assume interest is like accumulated at interest rate J. So right now, what you can think of is you can separate your account into two sub-accounts. The first one only has the principal. So at time one, it has $1. Okay. The second sub-account only has 5 cents, which includes the interest you have earned over the first year. And because the interest only grows at interest rate J, so here's, right? So for the second sub-account, 5 cents remains at 5 cents. That is the principal of the second account. Then it will accumulate interest itself, but it is at a different rate. Okay, now this is everything we have at time 2. So let's add them up. And we know this is 1.5 is 1 times I. The other one, it is also I, but the next one is I times J, right? So if I and J are the same, then our account value at time 2 will be 1 plus 2I plus I squared, which is 1 plus I to the second. That is why, over the time, we say this is the accumulated value factor, right? This is the detailed analysis. But if J is different, this does not hold. So that's something we're going to use to solve this question. Okay. First, let's do a timetable. So at time 1, there's $1 invested. Okay. When will you receive your first interest? The first deposit is at time 1, but the first interest will be at, so basically, on above this time, like an index or timeline, is our principal or our deposits. Okay. What I put below is interest. So the first interest is credit at time 2, and the amount is 1 times the interest rate, which is 5%. So here is 0.05. Okay, at time 2, Susan deposits another $1. So at this point, it's another. So let me see. Add another $1. So at this point, the total would be $2 in the principal, right? The first dollar comes from the first deposit, and then she adds another $1. So now at time 2, her principal is $2. Okay, this will give her 2 times 0.05 amount of interest, so 10 cents at time 3. So this and this, they are, you can think they are being saved in different accounts. So that's why, I use different arrow. Another $1 is deposit, making the total principal $3. So you can see this will be 3 times 0.05. So it's 15 cents. In the end, let's do one more. Okay, so obviously here she deposits another $1, so the total would be $6. Finally, adds another $1, so the total principal is $5. By the way, the last $5, in the end, stops there, does not go into any future interest, but this will, right? So now let's do the analysis in the future. So the total accumulated value at time 7 would be, first of all, by the way, one thing I assume is this Z is 1. Okay, if it's not 1, that's okay, because we are looking for the ratio, so they will be canceled. So it's easier to work with z being 1. So first, I have $7 in the principal, right? That is the each dollar accumulated over time. So since I calculate interest in a separate way, so here I only take care of the principal, that's only $7. Now let's take care of all the interest. The first interest is 5 cents, and I want it to be accumulated to times 7. So what I have would be the how interest grows, right? Interest grows at what rate? 6%. So when I accumulate interest, I will need to use 6%, not 5%. That is something really important. The number of years is obviously 5, right? Because in total we have 7 years, right? On the left-hand side, we have 2 years used. So the second one is 2 times 0.07 at 0.5. Now, obviously, you have 4 years left, right? Continue until the very last one would be 6 times 0.05, right? The last interest is paid at times 7. So there's no need to do any accumulation. So what we have is, obviously we can factor out this guy. So if you want, they are only limited, right? So you can write out everything. Right. So if you really want, you can use calculator to calculate all the numbers. In that way, there is no formula, right? And it's very easy to do. The number is about 23.23, and then you times by 5% plus 7, you'll get the result, right? But if you want, what's inside the square bracket is actually the future value. It is the future value of increasing sequence, right? Okay. But this is very easy to calculate given that we only have 6 terms. From here, the good thing is you can apply the formula, which could help you to calculate something more complicated. Like in the next case, we will not do the summation directly. But here, if you want, you can do the summation directly, and it's likely easier. Okay. Once we analyze the first person, the second one, it's pretty much the same, right? Except it's much longer period, right? So here you have $1, then here the first interest is not 5%. What's the interest rate? So it's 2.5%. So it's 2.5%. It's the first interest, right? So from here we can directly analyze. We know the total amount of principal is going to be $14 because there is a $1 deposit at the end of each year. So at this time, you're going to have $14. And here is obviously the interest rate. Right, I'm copying what I did for the previous person. The interest rate is 3%, so it's 1.03. We need to count how many years. In total, we have 14 years, right? We need to go to this, so it's 12. And the next one is 2, right? So the increasing sequence. And then this will go down. 3, 1.03, then it's 10, goes on. And finally, you're going to have the zeros term. So you will have 13. This is 0. Okay, it's easy to figure out because this is 1, right? 1 plus 12 is 13. 2 plus 11 is 13. 3 plus 10 is 13. So 13 plus 0 is 13. So this is how you figure out the terms. So I can write it as 0.025. This is obviously an increasing annuity, right? And this increasing annuity immediate. We want to know the future value. So I put IS. How many I have? I have 13, 1, 2, all the way to 13. Interest rate is 3%. Now we do need to know the formula to compute this. This will be, so it is the future value of annuity due, the same one, minus n, and then we divide by I because this is an annuity due, annuity immediate. So I refers to immediate. This, your calculator can directly do, remember this is the due. So if you use your financial calculator, you will need to set the beginning, okay, the payment to be paid at the beginning. But usually I don't like to do that. Usually what I do is I calculate, what I do is I do this. This is my personal choice. That's because I don't want to set the payment to be at the beginning and then reset it again, because my preference is always to do the immediate annuity immediate. That's why I constantly say if there's any formula you need to memorize the immediate, right? Because the due, the continuous payable, it's the same. All you need to do is to change the denominator, right? So usually I use that. For instance, in this case, in order to solve using your calculator, what you would do is hit 1, 3, and then hit n. Interest rate is 3, so I will hit 3, hit the button, this I/y, that is interest. Interest, you need to ignore the percentage. So you should hit 3 and then hit this button instead of 3%. The payment, let's use 1 for the payment. So for PMT is 1, then we can CPT FV, okay? And then you can use that times by, what's the number, 0.025, right? And then add to, this is about 16. So y over x is about 2. Well, it's about 2.0305. Okay, this question is rather complicated, and I don't think I will test you something this difficult. But the idea, I think you should know, because this is a complete analysis of how principal and interest each grows over time, right? And if you have the third year, you can still continue, right? So only the first one, only the principal one, the horizontal. So basically what I mean is the horizontal part is somehow the principal, and the dotted line with angle is how you calculate interest, right? So, oh, by the way, I think I made a big mistake down here. So if this is the, there is right, because we use I to calculate interest. That's I saw it wrong. Next one is 3.18. Mike buys Perpetuity immediate with varying annual payments. During the first 5 years, it's $10. Starting from year 6, it increases and forever. The current payment is K% larger. So basically, let's draw it. It's $10. Okay, during the first 5 years. This is the last time is 10. Starting 6, it grows. So this is what we refer to as compound growth, right? Because the next one will be 1 plus k squared and so on. Since this is a perpetuity, so it never ends. The interest rate is 9.2%. We know the present value, so we just need to figure out the equation for it. So This is somehow relatively easy to analyze because the first part is very easy, right? We have 5 equal payments of $10. That's an annuity immediate. Okay, then we have something we need to analyze. Technically speaking, this is what we call the PV of compound increase. This is a perpetuity. So perpetuity immediate. Okay. Remember, the first payment of this perpetuity starts at this point, right? So if you calculate the PV, it will be here. So it's in order to go back to 0, you need to times by a discounting factor of 5 years. So we can do quick calculation for this. This is about 38.9 or 0.7, 69955. So, but I don't want to use the formula. Okay, we do have the formula, right? You remember we need to get to the net interest rate J, right? So here is K and I. In our notes or in the textbook is E, right? The compound rate is E, and then we have I here. You need to convert it into I minus K 1 plus E. Okay, that is the net, what we call the net interest rate. Okay, of course, it's if you can memorize everything, that's good. You can apply that formula from there. But I don't want to do it. So first, let me subtract it to the other hand side. I want to directly analyze this. So I know my payments will look like this, right? I haven't taken care of the discounting yet. This is simply the payments. My first payment is here, right? So I have already taken care of this part. I have already taken care of. That's why I call this the first one. Okay, so the first payment is n is 1, then is 2. Now I need to figure out the discounting. Okay, what would be the discounting? Negative n plus 5, right? Because for this particular payment, the discounting factor would be v to the 6, right? Let's use v. Okay? I don't want to put negative sign down there at the moment. So we can just use v. Okay, the first payment is here, and you need to discount 6 years. 6 years is 1 plus 5. Here I need to discount back 7 years. It's 2 plus 5, right? So 5 can be taken out. Okay, 10 can be factored out as well. And then we know v is 1 divided by 1 plus I. So it's 1 plus k, 1 plus I to the nth. Okay, and then I have, what do I have? 1 minus the common ratio, and the first term. That's it, because this is a perpetuity, right? I don't need to do 1 minus v to the nth because n goes to infinity. So here's the case. So times by 1 plus I for both sides. Okay, we have this. Okay, and then we just need to calculate this k, right? Then we can move this to, or divide this to the other hand side. Then we get times this is about, it's actually about 200. 200 times I is 0.092 minus k equals 10 plus 10k. Okay, so basically I divide this over and 10 keep here. And then we get k equals, so we get k is actually 4%. So that is the second one. A third one is more standard. Okay, so for 3.19, I actually expect most of you to be able to solve this question. We have been doing this several times in the last um, videos. So here we have a continuous payment. Okay, so this is the payment rate, what we call rho. Interest is credited at the delta t is 1 divided by 8 plus t. After 10 years, the account is worth 20,000. This is account value or accumulated value at 10. Calculate K. So let's do this. By now, I do hope you feel comfortable with doing integral. The starting point of this annuity is time 0. The ending point is 10. The payment rate is 8K plus TK. Because we are doing future value, so it's exponential from the current time to the end time of your AV, which is 10. 1 divided by 8 plus S ds dt. Okay, so now let's do the inside part first. Okay, you should know log t, if you differentiate, is 1 over t, right? Of course, t has to be positive. So this is log 8 plus s. That's from t to 10. So let's factor out this k. So I have log 18 minus log 8 plus t. Okay, this is log 18 divided by 8 plus t, right? Okay, then exponential of log, it will cancel. So this goes down, this. So 8 plus t is going to cancel 8 plus t. So in the end, what I have, 18k is a constant. I take it out, times 10. So it's 180k equals 20,000. So k is about 111.1111. So it's infinite going on. The last one, a 20-year annuity certain pay provides payments annually of $200 at time 1, 180 at time 2, 160 at time 3, and so on until the payments have reduced to $60. Payments then continue at 60 until the 20th payments have been made. We know I 6% determines the present value. First, 200. Second, 180 goes on until how much? $60. So first, we need to know what would be the time at for the amount of $6. We know the decrease amount is 20, so the difference between 200 and 60 is 140. Okay, and we know the unit decrement is 20, so that gives you 7. So here's 8, right? Because 8 minus 1 gives you 7 years of decreasing 140. From that point on, it goes forever. So which means if it's 7 here, it would be $80. Goes on until the end, which is 20 years. We need to know the present value. Okay, all those are 60. So there are two different ways, right? So first, well, there are many ways of solving it. The easiest one is break those as 60, 20. So here would be 60, 120. So finally 60, 140. Okay, so we have level annuity immediate for 20 years. The amount is $60. That is the easy part to handle. Now let's deal with the decreasing part. right? So let's use blue. So it's decreasing annuity immediate for 7 years. Okay, that's why the last payment, well, you know, if I factor out 20, it's 7, 6, all the way to 1. So that's why, you know, you know there are 7 payments, right? The biggest one is 7, right? It's decreasing. The amount of decrease is 1. That's why we have a standard one. Okay, so this part you can easily calculate, right, from your calculator. It's about 815 for the first part. For this, uh, the formula for decreasing annuity is n minus the corresponding present value of annuity immediate. Interest rate is actually 4%. Let's keep the general formula. Okay, you plug in, you will get, this is about close to 500. It's about 499. So in the end, you add everything together, it's 1314. Okay, that marks the end of SOA questions.